In this second law of sines and law of cosine video, I'm going to go over some examples of how to actually use the two theorems. So, just a reminder, if before any of the examples you want to do them on your own, just pause the video and then go on. Okay, so first, there are many different cases. So one example, or one case, is where we're given two angles and one side of a triangle and asked to find the other sides and angles. So here we're given a triangle ABC. Angle C is 110, angle B is 50 degrees, and side C is 12. So first we have the law of sines, and we can fill in the information that we're given in our drawing. So we have that A over sine A equals B over sine 50 equals 12 over sine 110. Well, what else do we know? First, we know that the sum of the angles of a triangle are 180 degrees. So therefore, we know that A plus 50 plus 110 is 180 degrees. So we can solve for A, and we get that A is 20 degrees. So now we can plug in A being 20 degrees into our law of sines, and then we can solve for both A and B. So we get that 12 over sine of 110, or 12 over 0.94 is 12.77. So now we can separate this and solve the two separate equations. So we get that B divided by 0.77 equals 12.77, and that gives us that B is 9.78. And then similarly, with A over 0.34, we can solve for A, and we get that A is 4.37. And therefore, we have solved for the three unknowns in this problem. Now here is a second example. This time, we're given a triangle ABF, and we're told that one of the angles, A, is 30 degrees, the side little a is 4, and the side little f is 5. So instead of being given two angles and one side, we're given one angle and two sides. So we're going to start off the same way. We write down the law of sines, and then we fill in the bit of information that the problem gives us. So remember that sine of 30 is 1/2, and so therefore we get that 8 equals b over sine b equals 5 over sine f. So now, taking the 8 equals 5 over sine f, we can solve for sine f, and we get that 8 sine f equals 5. So now, taking the equation 8 equals 5 sine f, we can solve for f. So first, multiplying both sides of the equation by sine f, we get that 8 sine f equals 5. And then by dividing both sides of the equation by 8, we get that sine f equals 5/8. Now remember that sine f is not a one-to-one function, which means that there can be multiple values of f that get mapped to 5/8. Now we know that since dealing with a triangle, all of the angles are going to be less than 180 degrees. So in fact, if we're looking at what values of f are equal to inverse sine of 5/8, we get that f equals 38.66, and it could also be 141.32. So in fact, there are two solutions to this problem. Now, this can be easier to see if we look at a picture. So, remember this problem, we were given a triangle ABF, and we were told that angle A is 30 degrees. We were told that side F, so in this case that's side AB, is 5, and we were told that side A, or side BF, is 4. So if you look at this drawing here, I just drew a ray coming out from point A, or angle A, because we know that it's a 30-degree angle, but we don't know how long that last side AF is going to be. Now, if you draw a circle of radius 4 centered at point B, that's indicating all the places that side BF, which is length 4, where it could possibly be. And so you see that it intersects the ray at point F and at point G. So there are actually two different possibilities for triangles that we could get that have a 30-degree angle and two sides being 5 and 4. So if we're looking at angle AFB, that's going to be 38.66, and angle AGB is going to be 141.32. So now to solve for the remaining sides and angles, so side AG and side AF, we're going to have to use the law of sines twice. So first, plugging in angle AFB into our law of sines, we have that, so first plugging in AFB into the law of sines, we get that 8 equals B over sine B equals 5 over sine AFB. Now, since we know that angle AFB is 38.66, we can solve for our angle B, or our angle or our angle ABF. And so we get that B is going to be 111.34 degrees. So now, finishing the law of sines, we get that A equals, so now plugging into the law of sines, we get that A equals B over sine 111.34, And so multiplying both sides by sine of 111.34, we get that b equals 7.45. So that is the solution for triangle ABF. Now, looking at angle AGB, if we plug that into the law of sines, so now we're considering the triangle ABG, we can again solve for the angle B, which in this case is angle ABG, and we get that it is 8.68. Now plugging in that into our law of sines, we get that 8 equals b over sine 8.68. So multiplying both sides by sine of 8.68, we get that b equals 1.21. And so therefore we've solved for all the sides and angles of triangle ABG.